Yep, 1 over 2.5, because it's 2.5 moles per 1 liter of solution. Right? Now if we multiply this out, 10 times 0.5 is 5, divided by 2.5 should be 2.0 liters, and the units are liters of 2.5 molar HCl. I'd also accept liters of solution.
So you have to write it, the answer has to be 2.0 liters of solution, or...
Yep, so significant digits are important. And I'm going to say that this was 10.0 liters, 0.50, because I want 2 significant digits. But yeah, significant digits. And then you also have to indicate the units. And the units are not just liters, but it's liters of solution or liters of 2.5 molar HCl. Does that make sense?
And that's the answer?
Yep. 2.0 liters of 2.5 molar HCl.
Or you can do liters of solution.
Yep, or liters of solution. Yep, so unit-wise, we're going from liters to moles of NaOH to moles of HCl to liters of HCl. Or you might go from grams of something to moles of something to moles of something else to liters of that something else.
But isn't that practically what we did on the last test, though?
With the exception of molarity, yes. Yep.
But if we do grams, will we have to use molarity if we do grams, though?
Yeah, you still need molarity right here.
Oh. Cool.
So what kind of converting are we going to do, like, compared to what we had on the last test?
The only converting that we've introduced new is molarity. And then all the gas stuff.
Oh.
So the gas stuff is just using the equations. There are really only three equations to remember. There are really only 4 equations to remember.
Equations like problems like this we're going to have, or like equations just like what's the equation for, like,
well,
Like all the laws?
yeah,
I'm
so
trying to
laws are
think of
helpful.
what you're talking about, equations like the...
So the equations that you'll want to know are percent yield. And percent yield equals what? Actual yield over theoretical yield times 100%. Okay, you want to know that. A second one is P total equals what?
P1 plus P2 plus P3.
Yep, P1 plus P2 plus P3 plus P sub n. Okay. The third one you want to know. What's the combined gas law?
Did it say P1 plus P2 plus P2?
That's 3.
Oh, okay, sorry.
What's the combined gas law?
Is that the
P1V1 over T1.
P1V1 over T1 equals?
P2 over T2?
Very good. And any combination therein. So it might be pressure remains constant, volume remains constant, temperature remains constant, or it doesn't. And then, what's the ideal gas law? That's the other one. PV equals nRT. You don't have to memorize R. I'll give it to you. But you do need to memorize the equation. PV equals nRT. So those, I think, are the only 4 that I can remember that we covered. Let me double check. I think those are the only 4 that we covered. That's that problem. That's that one. Well, I guess besides the definition of molarity, which the definition of molarity is moles of solute divided by liters of solution equals molarity. But yeah, those are the only kind of math equation kind of things that we need to know.
And we've got to know all of those, like,
Yeah, I won't give you them on the test. They'll be worked into problems that you'll need to solve.
can you do one with like the, like one with the P1 and D1 over, like, one with that and then one with that?
This one?
Uh-huh.
And one with
That.
this one? Yes.
But you're probably going to mix up that equation to where it's not just like that, it'll be something else. Kind of.
Yeah, you'll need to isolate whichever one you want.
Yeah.
And I won't make you isolate a T2.
Like, how do you know what's P and what's V? Are you gonna?
Well, what units will you have on P?
Yeah.
Yep, atmosphere. How about
Oh,
V?
okay, I get it.
Usually
Yeah.
liters.
Yes.
And T.
Degrees Celsius that we have to change.
Or,
Kelvin.
yep, it could be Celsius or Kelvin. If it's Celsius, make sure you change Celsius to Kelvin. Because this equation only works for absolute temperature, which is in Kelvin. So let's do them like that.
So you're probably going to use the
Celsius, do
volume.
you just do Celsius plus like 273? Is that right? Is that-
Yes.
is that
Yep.
what
Celsius
all
plus
you do?
273.
Okay.
Right, so let's say you've got O2 gas at, suppose I need to give you a volume. You've got 10.0 liters of O2 gas at 15 degrees Celsius and 10.0 atmosphere. Right. Your temperature and pressure change to 20 degrees Celsius and Celsius. Let me see. We've increased. So we need increase. Okay, and 15 ATM. What is the new volume of O2? Yes. Right. So what are we looking for?
V2.
V2, very good. Right, so we want V2 on one side. So what do we have to multiply by to get V2 on its own?
V2 over T2.
Multiply by, say again,
P2 over T2.
close,
T2 over P2.
T2 over P2,
Okay.
because we want T2s to cancel and P2s to cancel. Yep, so multiply by T2 over P2 times P1 V1 over T1.
You just do that because when you swap it, they turn negative and they just cancel each other out. Is that what's up?
Yeah, we want